welcome to our webinar. This is Dr. James Rippey. It is my pleasure to serve as the moderator for today's webinar. I will formally introduce our faculty, Dr. Andrew Brown, momentarily. Before we begin today's webinar, I would like to give a special shout out to registered dietitian nutritionists and dietetic technicians registered for all the great work that you do, and join you in celebrating National Nutrition Month. Today's webinar is part of the Conagra Food Science Institute, the NutriBite webinar series. The mission of the Conagra Food Science Institute is promoting dietary and related choices affecting wellness by linking evidence-based understanding with practice. Before I introduce today's faculty member, I would like to turn the webinar over to Amy Continelli, who will give you some logistical information concerning our webinar. Amy?
Thank you, Dr. Rippey. A link to obtain your continuing education credit certificate will be emailed and available on this webinar's page at our ConagraFoodScienceInstitute.com website within 2 days. A recording of today's webinar, the slides, and summary PowerPoint will be available as well to download as a PDF within 2 days at our website. The presenter will answer questions at the end of this webinar. Please submit them by using the chat dialog box on your computer screen. Thank you, Dr. Rippey.
Thank you, Amy. Today's faculty, as I mentioned, is Dr. Andrew Brown. I will introduce him momentarily. Today's learning objectives, as you all know, this is a CEU activity for the Academy of Nutrition and Dietetics, and the learning objectives are the following. First, review potential influences of biases in nutrition research. Secondly, discuss the importance of critically evaluating new research, that is, whether it confirms or refutes standard clinical practice or commonly held beliefs. Third, describe steps to minimize misinterpretation of research. Fourth, identify strategies health professionals can use to objectively translate scientific knowledge to clinical practice. It is now my pleasure to introduce today's presenter, Dr. Andrew Brown. Dr. Brown is a scientist with the Office of Energetics and Nutrition Obesity Research Center at the University of Alabama at Birmingham. Formerly trained in nutrition, biochemistry, and statistics, he brings practical basic science experience to evaluating how nutrition research is conducted and communicated. His recent work involves investigating myths and presumptions in nutrition and obesity literature, meta-analyzing studies about nutritional influences on obesity, characterizing reporting practices that may perpetuate nutrition misinformation, and crowdsourcing the synthesis of published research. Dr. Brown has received local, regional, and national awards and has spoken internationally about integrity in research reporting and science communication with respect to nutrition research. It's now my pleasure to introduce Dr. Andrew Brown.
Thank you, Dr. Rippey. Today's talk we have titled In the Eye of the Beholder, Critical Evaluation of Nutrition Research. And I just wanted to start by saying that when I talk about critical evaluation, I don't want to bring up images of dismissive evaluation, but rather to really consider, are the questions we're asking answering the questions we think they are, what types of background information are we bringing to these questions, and just really looking at the questions with a little bit more of a critical eye. So the first slide here is acknowledgments and disclosures. The two most important things on this slide to me are I wanted to thank colleagues who may have helped with the slides. I say may have helped because we often will make slide sets together, and I have the privilege to work with some really great individuals here at UAB. And on the other hand of that, I also want to say that what is said here reflects my views, and if you don't like it, blame me, not them. So to start with an outline, I wanted to begin just by considering how we know things about nutrition. And I found one of the best ways to kind of consider that was with an analogy that came up when I was speaking to a pastor one day. And I was told a little bit about this idea of a Wesleyan quadrilateral. So Wesleyanism is a denomination of Christianity, and Outler had discussed a way that people kind of understand spirituality. And forgive the fact that this isn't actually a quadrilateral, so geometry aside, the different ways that people kind of understand their spirituality was, bringing in things like tradition, what has their culture done in the past, their individual experiences, how do different things make them feel, reason, which is just do things make sense with everything that they know put together, and then they also considered Scripture in this case to be the center kind of guiding force. And when I looked at it, I thought that really reminds me of how we kind of understand nutrition, because it's also a very personal type of consideration to make. And so people think about the traditions of the way they eat and their cultures, what their families have consumed. They consider the experiences when they eat a particular food. How do they feel? Does it make them feel happy, good, bad, sick? And then reason, which is, when people are eating things and somebody's told them that something is unhealthy, they can process that and think, okay, why would this be so? But I also think research should be at the center in terms of recommendations and understanding human health. And so I thought this was a reasonable analogy to help us frame how we each see things through different lenses when it comes to knowing things in nutrition science. And Outler, when talking about the Wesleyan quadrilateral, I've changed, instead of an individual, I put nutrition scientist here instead, but the quadrilateral requires of a nutrition scientist no more than what he or she might reasonably be held accountable for, which is to say a familiarity with scientific literature that is both critical and faithful. So again, we bring in the idea of being critical but not dismissive, plus an acquaintance with the wisdom of nutrition science history, plus a taste for logical analysis as something more than a debater's weapon. So I wanted to kind of frame things in terms of really trying to consider how we make decisions about what is and is not true in nutrition science. So knowing that we come at nutrition from very different angles, I think it's important to consider whether we're even using the same language. And here is a list of some words that I often like to bring up in terms of different definitions that people might use. So one word that we see often is nutritive, and one definition of that is that it contains micronutrients. So you'll hear things being, not having nutritive value, and that means, some people mean it as it doesn't have vitamins, etc. But there's also the idea of, for instance, nutritive sweeteners versus non-nutritive sweeteners, which is the idea of containing calories. So when we say something has no nutritional value, which of the two are we actually discussing? And similarly, through with some of these other examples, people use significant to mean important, but me personally, I spend so much time reading the research that when I see significant, often people mean it has a p-value less than 0.05. For reducing, you can either use it as decreasing or actually a chemical process. Toxicity, people use that to mean that it's acutely hazardous, this food is toxic. Whereas there's more of a toxicological definition of a generalized capacity to cause harm. Uncertainty, I think, is a very big one for nutrition and science in general, because when we as scientists say that we're uncertain of something, some people interpret that to mean that we're saying anything is possible. But usually it means that we know within, some level of boundaries an effect of something. And so those are two very different uses of the word uncertainty. Obviously, this crowd will be familiar with diet, meaning, a particular set of restricted behaviors, or just, what type of diet do you eat. And then bias can either be a mathematical deviation or human distortion. So clearly, even just in these definitions here, which are often used in describing nutrition and nutrition research, we could be talking about very different things. So if we move on to even more abstract concepts, we were trying to evaluate what evidence has been looked at really in terms of snacking and meal frequency on obesity. And we found that it's very difficult to find out what people even mean by a snack or a meal sometimes. And so researchers had defined snacks and meals in different ways, and here's two examples where it's defined specifically by time. So if you eat between 8 and 10 a.m., that's breakfast. 12 and 2, that's lunch. And 6 to 8, that's dinner. Well, obviously people eat at different times, and so at least one study said that if you're eating at different times, it's a snack. Well, that's a definition, but I don't think it's one that everybody would agree on. Then there's also by food composition type. So, is it a small food, a healthy food, lots of calories, few calories? But then it gets interesting when you ask people. Individuals, what they define as snacks and meals. And Monsink and others looked at that very thing and saw meal-related perceptions versus snack-related perceptions in individuals. So if you're eating with the family with a cloth napkin, sitting down, and it's an expensive, prepared, healthy food, people tend to think of that more as a meal, whereas if you're eating alone with a paper napkin, standing while eating, inexpensive, packaged, unhealthy food, you might think of that as a snack. And so when you put these together and you're trying to do research on this type of a question, if you're sitting with your family and you have, let's say, a breakfast with a bagel, eggs, bacon, maybe some orange juice, and you're sitting together, at a table and the meal's prepared, then that might be considered, a breakfast meal. But if you were to have it at, let's say you go by a food truck in the morning and get a bagel, bacon, egg sandwich, and orange juice on the run, and they give you a paper napkin, and you're eating it at 10:30, is that all of a sudden a snack? So it sounds a little bit contrived in that way, but it brings up really serious issues when we talk about the health effects of snacks versus meals. We also get into issues where we use words like healthy and unhealthy as though they actually have standard definitions. And so I looked at using the Google Books Ngram Viewer, where they catalog all the words and all the books that they have on Google over time, and looked for some of the euphemisms for bad foods and how they've changed over time. And you can see since the 70s, the phrases about junk food have really kind of increased. But I thought, phrases like bad food was interesting as well. Now a lot of times you'll hear people talk about bad food as unhealthy, but it used to be food that had spoiled or might have had some other contamination in it. And so what words we're using for some of these abstract concepts have changed over time. And back to the nutritive value, you can see the USDA Farmers Bulletin in 1917 said, the common fruits, because of their low nutritive value, are not, as a rule, estimated at their real worth as food. So I think today most people would say that fruits are, a very high nutritive value, but at the time they were talking a lot more about calories. So, fruits provide a lot of micronutrients, and a number of fruits don't necessarily supply a lot of macronutrients. So it's a completely different use of the word nutritive over time. Fast forward to 2012, and we get phrases like, we encourage parents to stop serving cheese, meat, and other junk foods to children. This was a comment made by the Physicians Committee for Responsible Medicine, and at least in my circle of individuals, when I share that sentence with them, they're taken aback because they had never considered cheese and meat to be a junk food. So if we're just telling people to avoid junk food, what is it we're even meaning? Again, in the research realm, if we're just saying, classifying what people eat as junk food or not junk food, how do we actually look at associations with health? So I thought one way I could illustrate the different ways that we interpret the healthfulness of foods is to use this example by Rosin, Ashmore, and Marquith in a paper they had published. And they asked individuals, and this is a question I would like to ask you, assume you are alone on a desert island for 1 year, and you can have water and one other food. So pick the food that you think would be best for your health, never mind what food you would like, and then check the food you would pick. And so the options they gave were corn, alfalfa sprouts, hot dogs, spinach, peaches, bananas, or milk chocolate. And so if you wanted to go ahead and vote now on which of these, oh dear, it looks like the answers might have gotten changed on here. Let me see. Yeah, these are actually the answers for our next question. Dr. Rippey or Amy, should I just move on to the next?
Lou Alice. I would say move on.
Here we go. It looks like it's up.
All right, here we go. We're back in business. Okay.
All right. Fantastic. Man, that's amazing how fast you all are able to do that on your end. That would have taken me forever. So, all right. And it looks like people are voting, so that's great. And I'll give maybe a few more seconds here. Well, they're still coming in pretty fast, so I might give a few more seconds. But so just to give a little more background on this question, this is one that they asked a group of individuals, and I'll show you on the next slide, and had published this paper in the late 90s. So at this point, I think we'll go ahead and move on to the results. Oh, where'd they go? There we go. So these are the results of this group. I'm actually surprised to see milk chocolate so high. And this group in particular, I think, would probably have a better grasp on this, and I'll show you the results of the study by Rosin and others. But it gets to be a little bit difficult to determine what is the thing that is going to be the most important for your health on a desert island. So it looks like a full quarter of the group thought milk chocolate. And, in fact, that is one of the two answers that Rosin and colleagues had thought would be one of the best foods of the options here. Probably not the best of all options, but when they asked students, physical plant workers, a national sample, faculty, and students, they also asked students saying that they would have oranges because some of the students were concerned about vitamin C, so they just gave another group of students that question. But you can see a lot of people had voted for things like spinach. And it's not likely that you'd be able to get enough calories from spinach over the course of a year. And so when you think about what things you need to live for a year, obviously oxygen first, water second, energy third, and then you would need essential nutrients. And so it's just really interesting to consider the way that we look at foods and the healthfulness of foods. And yes, people have criticized this example as potentially being too contrived. You know, you're talking about a desert island. How many of us really have that situation? But I think it's useful for two purposes. One, it helps us kind of think of the way we're coming at the nutrition. What are the things we're placing a value on? But I think there's also another point to consider, which is different people in different settings are going to have different requirements, and that's obviously something that dietitians and nutritionists are used to addressing regularly. But, are the requirements of athletes versus elderly versus pregnant individuals going to be the same? Similarly, is it going to be the same if I'm trying to decide what to eat for breakfast or if I'm going to be stranded on a desert island? So that kind of gets at some of the challenges in determining how we know things about nutrition. What language are we using? Are we even discussing the same things when we talk about health or junk? And so if we have a hard time defining that as individuals, it can also be a little bit difficult to define in research. And so I wanted to talk a little bit about how to critically evaluate some of the research to minimize some of the misinterpretation. And the things that are important to consider are things such as what exactly was studied, how was it studied, and how does that compare to how it was communicated. So I'd like to begin using this example, which Michelle Boham-Brown, my wife and colleague, had presented to me. She came across this one day, and the paper is titled Postprandial Energy Expenditure in Whole Food and Processed Food Meals, Implications for Daily Energy Expenditure, or as she called it, The Tale of Two Cheese Sandwiches. So I don't think inherently there's necessarily anything wrong with this study the way it was conducted, but there might be some concerns for the representativeness of these two cheese sandwiches to represent all whole food and all processed food. So to give a little example of what they did in this study, they showed that for the whole food group, they used bread that was multigrain bread with whole sunflower seeds and whole grain kernels versus a processed food of white bread. So some people have argued that even the whole grain bread is going to be a processed food. So now we've got issues with the definition, right? But even beyond that, is this representative of all whole food or processed food? So we see that in the one group they used cheddar cheese and the other they used a processed cheese product. But we also have to look at the fat composition's different, the protein composition's different, the carbohydrates are different, and all of those affect postprandial thermal effects of foods. And indeed, when you look at the sandwich itself, to make this work, the whole food sandwich was 2 slices of bread with 2 slices of cheese, and the processed food was 3 slices of bread with 2.28 slices of cheese to get the same thing. So, this is a reasonable way to compare one cheese sandwich against another, but then we have to ask, is this representative of all whole food and processed foods? And the only reason why I bring this one up as well is because very few studies have been done on this topic, and this is actually the only one that is cited on Wikipedia. So this is the only information that is widely out there about thermic effect of food on whole versus processed foods. So, looking at it with a critical eye, we need to consider how representative it really is. Now, that was talking about the exposure in a study. What about the assumptions made about outcomes? And there was a recent paper where they were attempting to model, it was titled Modeling Potential Effects of Reduced Calories in Kids' Meals with Toy Giveaways. And we had written a letter that we titled Order of Magnitude Misestimation of Weight Effects of Children's Meal Policy Proposals. So the group that did this did a really interesting job pulling data from a number of different places. But the one assumption they made that ended up being a little bit problematic is the idea of the 3,500 kilocalorie rule. And that's the idea that if you increase or decrease the number of calories you eat by or expend by 3,500 kcals, you'll change your weight by a pound. And there have been validated methods, and the one we used was by Hall et al., that show that that doesn't necessarily translate directly, so the body adapts quite a bit. And when we look at the 3,500 kcal estimations, this is saying that using a 485 kcal per meal policy to limit children's meals to 485 kilocalories, that you would expect a child to prevent 23 pounds of weight gain. Whereas with the validated method, it's only a half a pound. And this gets even more extreme with the 28-plus fast food meals per week, which, according to their data, 3% of children were eating over 4 meals a day from fast food restaurants. You see quickly how the model starts to fall apart because you're talking about 327 pounds. After we brought this to the author's attention, they very admirably retracted that paper, which is something that a lot of people wouldn't do, so we were very impressed by the group. But unfortunately, groups like DASH New York had already picked it up into their database where it says the purpose of this collection is to make information on obesity, prevention policies, and the underlying evidence base easily searchable and accessible. So this mistaken assumption has already been somewhat perpetuated, and that's something we have to keep an eye out for. So one other thing we can consider is, do the methods even tell us what we think they do? So a lot of times we'll collect data, and sometimes we'll assume that they are meaning something that perhaps the data aren't actually telling us. And here's one example where Schaefer et al. Had tried to look at whether you could get people to report exactly what they're eating using a food frequency questionnaire. If they know what they've been given, they knew exactly what foods were given. They told the participants what foods they were given. They were given a meal list, so they knew everything in the food they were eating. And they were given 3 different diets. They were given either a usual American diet, a National Cholesterol Education Program diet, or a very low-fat diet. And afterwards, they gave them a semi-quantitative food frequency questionnaire. And what we see, the way I set up this table is I kind of made it like a heat map. And so anything that is blue is being underreported. and anything that is red is being overreported. And anything that is in a bold outlined cell is something that was significantly different at p less than 0.05. And so in this case, you see that there are a lot of times where the nutrients that are being estimated by this food frequency questionnaire are off from the true values that are known by the researchers. And it can be a little bit problematic as well. If everything was blue, you would say everybody's just underreporting and maybe you could do a correction factor. But here, for instance, the saturated fatty acids in the National Cholesterol Education Program was overestimated by 113%. So we might, when we're asking people what they eat, we might not really be getting an estimate of what they're actually eating. Similarly, it seems that something that some people have called a diet image correlates with underreporting. So there's this concept of a body image, which is what somebody thinks their body looks like. So a person could think that they are a lot more obese than they really are, or a lot skinnier than they really are, and that's the idea of this construct of body image. Now, how much somebody actually weighs is objectively measurable. What somebody feels about what they weigh is a little bit more difficult to ascertain. Similarly, asking people what they eat has been proposed to be kind of a diet image, where I believe it was Adam Drewnowski had kind of brought this up after the Schaefer study that I just showed you, the idea that it's the impression somebody has of what they eat over a long period of time. And you can't really determine somebody's impression of what they eat, but hopefully we could determine what they actually eat. So what this group did was they looked at the total energy expenditure measured by doubly labeled water, and that's kind of our gold standard right now of free living energy expenditure. Then they looked at energy intake using the food frequency questionnaire, and then they also looked at the dietary patterns that people reported using the food frequency questionnaire. And what they saw was that there was kind of three patterns that came out. There were people that ate a lot of sweet things, there were people that ate a lot of starchy things, and they had another pattern that they considered a healthy pattern. For somebody to maintain weight, their energy intake needs to be at least needs to be equivalent to the total energy expenditure. And what we see is that as it goes from the sweet to starchy to healthy, people are increasingly underreporting how much they are actually consuming. And you can see that underreport can be as much as almost 50% of the calories that they're eating. So when we ask people the total energy of what they're eating, now all of a sudden we're not sure if it's measuring what we think it is. And the reason why that can be important is if we're trying to say what it is that people across the country are eating, we might not actually know it if we're just asking them. And this is a problem that's been known for quite a while. So in the Journal of the American Dietetic Association in 1953, there was a study where they looked at one-day food records versus a research dietary history. So the one-day food record is asking the participants what they ate, and the research dietary history was the staff actually watching what the women were eating. And they concluded that it appears, therefore, that unless special precautions are applied to the study of the fourth of the adult population which is overweight, any data collected on the caloric intake of populations by the record method is likely to be an underestimate. So here we see, if you look at the graph, the overweight women thought they were eating a lot less than they were. And this led a group of us this last year to put out a call to kind of stop using these data. And we said we offer the contrary view that self-report measures of energy intake are so poor as measures of actual energy intake that they no longer have a justifiable place in scientific research aimed at understanding actual intake. So it's really difficult if you're a lay or casual reader of research to understand that these methods have those limitations, and that's why we need to kind of give things a little bit more of a critical eye. One concern I personally have is what do we do with these data that can be somewhat problematic? And so the 2015 Dietary Guidelines Advisory Committee report just came out, and they state in it most of the data analyses used the National Health and Nutrition Examination data. So there's a lot of great data in the NHANES data set that are objective, but they used the self-reported dietary component of what we eat in America, and as we've seen, it's not entirely clear if that is a true measurement of what people are eating. So it's something that we have to continually critically evaluate. So let's move on a little bit to how the research is communicated. So often people, especially some researchers, will do some hand-wringing and complain that the news is misreporting their studies. And so there was a group that looked at how the media were reporting the studies. And what they saw is that in general, the media are covering inferior study designs. So the gold standard of causation is a properly controlled, randomized controlled trial, and that is according to the hierarchy of research designs they used, is the portion of the pie chart that is represented by the number 1. And then they have controlled trials without randomization and cohort or case control studies. And then they have time series with or without the intervention. So they concluded that the media are covering inferior studies compared to high-impact journals. But I don't personally think that's the entire story, because if we look at everything that's being published, since 1965, there's been close to 1 million nutrition-related studies published and indexed in PubMed, and that's the National Library of Medicine's index of research. About half of those were in humans, but less than 10% of those were randomized controlled trials. So although we could ask the media to try to focus on the higher quality of evidence, at the same time, there's not as much of that evidence that's actually being generated, so that's a very difficult thing to do. Similarly, there's bias that's presented to the public in the publications themselves. And so Yavshitz et al. Looked at what they called spin. And spin is the idea of specific reporting strategies, intentional or unintentional, emphasizing the beneficial effect of the experimental treatment. And I think it's really important to focus on the intentional or unintentional, because when we critically evaluate the research, we're not saying that people are doing things in an underhanded way. We're just trying to bring a new aspect to the way that the research is interpreted. And so if we look on the left-hand side, we look at the abstracts of these randomized controlled trials that were published. And we see 17 of them had what they considered to be spin. And if you look at the press releases of those studies, they also have spin. And when you look at the news related to those press releases, they also have spin. But if the abstracts are communicated in a way that doesn't have spin, then the press releases don't seem to have spin, and neither does the news. So we can't say whether the abstracts themselves are causally influencing this, but we can see that there's at least a correlation there. It could very well be that the 17 studies with spin were also fundamentally different questions, but it does raise the question of whether or not the reporting of the original research is part of the issue. One thing that we can say is that this group had a follow-up study where they presented clinicians with studies that either had spin or didn't have spin, and otherwise the studies were the same. And when the abstract had spin, the clinicians were more likely to want to read the paper, had a little bit more interest in it, and so we know that the way that a study is communicated does influence the way that it's read, and that just means that we have to be collectively vigilant when we're reading the papers to make sure we're bringing our own thoughts and interpretation to the data as well. Now, another idea of that, so those other studies I was talking about were randomized controlled trials. And observational studies, there can be other types of bias as well, and this is just one example of selective reporting, and this can happen in randomized controlled trials as well. In this case, the idea is that a number of these studies looking at the association between breakfast and obesity were looking at a number of different outcomes. So it wasn't just one-to-one breakfast to obesity. A number of these studies looked at a number of factors related to a number of health conditions. But what we saw is that if there was an association in the study that showed that breakfast was associated with beneficial outcomes, we saw that it was mentioned a lot more in the conclusions. If they didn't see that, if there was either no evidence that breakfast was beneficial or that breakfast was detrimental in the association, it wasn't mentioned at all. And so that's also something to be concerned with as well. So now what's another type of thing that we have to watch out for? Here's an example of what I've kind of called a stubborn preconception. In this case, we can actually see spin across a bit of a timeline. So this particular study had an abstract that was presented at a scientific meeting, and it was a water intake and metabolic syndrome risk, a randomized clinical trial. And in their abstract, they said, our findings do not lead to conclude that sugar-sweetened beverage replacement with water does not support reduction in metabolic syndrome risk factors, but rather that, and this is my own emphasis, intervention provided was ineffective in reducing other sugary beverage intake. So they're saying that their treatment ended up not working, not because it wasn't effective or wouldn't be effective, but because the people didn't stop drinking the other drinks. But then when we see the paper as it's finally published, we see a 9-month change in beverages with sugar, and in fact it did work. Their intervention actually got people to decrease their sugary drink amounts. But instead of continuing with what they saw in their abstract, which the data were quite similar in the paper, they changed the focus to this new title, which is Substituting Water for Sugar-Sweetened Beverages Reduces Circulating Triglycerides and the Prevalence of Metabolic Syndrome in Obese, but not in Overweight, Mexican Women in a Randomized Controlled Trial. When you actually look at the paper, that is just one of a number of tests that was done, and it's not exactly clear that it was actually effective. So here they just took the results and focused on this one thing that supported their hypothesis. And the reason why I bring this up in particular is it's particularly unfair to lay or casual readers because it's almost undetectable unless you go back and read all these different aspects to figure out what was actually done in the study. And then there's some times where the bias is just right in your face, and in this is an example of one we read where it's the consumption of takeaway and fast food in a deprived inner London borough. And the results actually showed that based on our observations, it appears that those who have higher BMIs are less likely to consume fast food as often. So, that's the opposite association that most people would think. Most people think that if you eat more fast food, you'll have a higher BMI. And this was the opposite. People with higher BMIs consumed less fast food. Yet they conclude these school children are exposed to an obesogenic environment, and it is not surprising that in this situation, many of these children are already overweight and will likely become obese as adults. So we pretty much did a study where in this case, the conclusions just state what they wanted to say, despite what the results actually showed. And it's difficult to pick these things up in casual reading of science. So what can we do about it? How do we actually translate science to clinic or policy? One example that I like to give is the idea of empty calories. So let's say that we actually have great, good, solid, hard evidence that decreasing empty calories is beneficial, whether it's decreasing them ad libitum or whether it's decreasing them in a controlled setting. The question is it useful as a recommendation? And so as I was going through the USDA's website, I came across a table of the number of empty calories in different foods. And so I thought this might be another fun question to ask this group. And that is, which of the following has the greatest number of empty calories? 5 ounces of table wine, 2 ounces of pork sausage, 3 ounces of roasted chicken thigh with skin, 1 cup of frozen yogurt, 3 ounces of regular 80% lean ground beef, 1 medium 2-ounce croissant, 1 cup of fruit-flavored low-fat yogurt, 1 small 2-ounce blueberry muffin, or 3 1-ounce slices of beef bologna. So if you wanted to vote on this one, which one has the greatest amount, the greatest number of empty calories? And I know this one I posed this question to people around here as well, and I certainly didn't get the right answer the first time I put it together. So I'll give another few seconds here. All right, 5, 4, 3, 2, 1. All right, let's move on to the answers then. All right, and so what did people say? So hopefully the results are up on everybody's screen there. And a lot of people said the table wine, which is something some people would guess around here. And it looks like croissant is the second. And if we go to the actual table, and this is directly from the Choose My Plate, where they talk about empty calories, we see that the greatest number of empty calories is fruit-flavored low-fat yogurt. So I think if you, especially the dietitians in the audience, I think if you were to ask many people if they thought low-fat yogurt was going to be a healthy option, most of them would probably say yes. That's just my guess. But you can see here that it has the greatest absolute number of empty calories, and you can see that the total calories, I made sure to pick ones that were kind of in a reasonable range with the exception of table wine. And I made sure to show that for the beef bologna, yes, it had the highest total calories, but it had slightly fewer empty calories. So when you look at this and you look at the responses from the question here, you have to wonder, is recommending decreasing empty calories useful if people don't have any sort of an intuitive understanding? And that's not a question we can answer on the fly. That takes a lot of policy research as well. But one thing I found particularly interesting was the 5 ounces of table wine. And I just put that in there because they say that every calorie in table wine is an empty calorie. So we're getting a lot of conversations lately about the Mediterranean diet, and some of the recommendations are to drink. If you drink in moderation, which is 1 to 2 glasses a day, and yet here we've got a situation where that goes against another criteria, which is to decrease empty calories. And to give an idea of what that looks like, this is also from the Choose My Plate website, where females 31 to 50 are only allotted 160 empty calories a day. Males are only allotted 265. I'm not entirely sure why males are allotted more. I need to look more into that. But I can tell you that if a woman had a roasted chicken thigh with 5 ounces of table wine, she would already be over her daily allotment of empty calories, despite I think a lot of people would think of that as not that unhealthy of a meal. So we have to think about, what are we doing with some of these constructs? How are we communicating them? What do they mean? What is an empty calorie? And this is a figure we made for a paper where we were discussing breakfast, and instead of food X is bad, this was actually considering that breakfast was good. So you can either do food X is bad or food X is good, and invert things as you see fit. But as we go through and look at all the literature that says a particular food is bad, and all the news stories saying it's bad, or all the stories saying it's good, that can kind of get this idea of the mere exposure effect, which is we hear things over and over, and then it's something that we retain. Then there's the idea of there's information that we'll discard if it disagrees with us, and I certainly as guilty of that as anyone else. There's foods I like to eat, And if I can find research to support it, sometimes I gravitate toward that a little bit more. And so it does take active effort to really look at things scientifically to figure out what would be best for recommendation or society. So I want to talk also about anecdote versus data, and this is something I know a lot of people are familiar with, but lately there's been more and more conversation about responders versus non-responders, and the idea of, we've got responders to a particular diet, which means that, you see a response versus non-responders, which is either you don't see a response or you see a negative response. In some cases, it can actually be detected. So sodium responders, for instance, you can give them a dose of sodium, and you can see if their blood pressure goes up. So that's something where we can actually determine if somebody's a responder or a non-responder. But let's say we put somebody on a National Cholesterol Education Program diet and look at their blood cholesterol. And you see that their blood cholesterol goes down, but there's no control group, obviously, because it's just an individual. And if it's a moderate improvement, it's unclear if the improvement was spontaneous, so somebody's seeking treatment, maybe they're paying attention to other parts of their diet. Maybe it would have been even better with another option. And if it shows something negative, let's say the blood cholesterol went up with the National Cholesterol Education Program diet, it could have been that had they been on a different diet, it would have been even worse. So the idea of looking at an anecdote and the individual makes it very difficult because when we think of things in a scientific context, we think about determining whether, on average, a group does better under one condition than another. And RCTs in particular tell us whether a change in exposure causes a change in outcome, and that gives rise to the little phrase that the plural of anecdote is not data. But I want to come back to that nutrition quadrilateral and really think about what are we talking about? What are we talking about, clinic, policy, or general science? And when we think about a clinician actually works in the world of experience and anecdote more often. You talk to the individual, see what traditions they have, the reasons for eating, and if the patient comes back and says they don't like a food or it makes them feel bad, it doesn't matter what amount of research says to eat that. I always use the example of peanuts. If we had a bunch of research that said peanuts were the best food ever, which is not, that's contentious, but if we said that the peanut was the greatest food ever, and you have somebody who's allergic to peanuts, I think the experience would trump the research in that case. So when we're reading research, we really have to consider, are we looking at this at an individual level? Are we looking at this at a policy level? Or are we looking at this as a generalizable principle that we can call a scientific fact? So to close, I just presented a couple resources here. A shameless plug for our obesity and energetics offerings. We go through every week and try to find some really great research to share with everybody. There's healthnewsreview.org. They go through news stories about various things in health and really pick apart how well they're reporting it. Sense About Science has great information about uncertainty, statistics, and other aspects. And the National Health Service in the UK goes through some of the science behind the headlines. So at this point, I'd like to thank everyone, and if there are any questions, I would be happy to take them.
Thank you, Dr. Brown. Before we go to the questions, I'd like to say, as a subscriber to your weekly obesity and energetics offering, I find it wonderfully helpful. So kudos to you and your team for doing that. David Allison, of course, has been very prominent in this, but it's a great reference. Okay, question number one takes us back to the desert island. What is the best thing to eat on the desert island, or not on the island, out of that list? I think a lot of people wondered at the end if you gave the answer.
Sorry, I might not have made that clear. Rosin and others were talking particularly about protein. And so that was one of the things they wanted to bring up. But if we go back and think about the foods that were available, it's not likely that you'd be able to get enough calories from something like spinach or alfalfa sprouts. Certainly with spinach, if you could get enough, you'd be worried about, some other phytochemicals in there that you might be overdosing on or have some GI issues. But they focused particularly on protein wasting. And so the milk chocolate and the hot dogs would each have complete proteins in it. And so that's why I mentioned, obviously you need oxygen followed by water followed by energy, and then you need the essential nutrients like complete proteins. Although the vitamins and minerals can be important, often you would have issues probably with protein wasting before you would have serious outcomes from some micronutrient deficiencies. But they also conceded that there are different viewpoints as well.
Thank you. So score 1 for hot dogs and milk chocolate. Second question. Perhaps the underreporting of calories might be due to possible higher exercise levels and therefore a need for greater number of calories. What's your opinion on that?
Yeah, so there's been, I've heard the number 200 thrown around, 200 different potential moderators of self-reported intake versus actual intake. So whether it be males versus females, body weight, exercise, dietary patterns, there's all kinds of different situations where it's unclear why the self-reported energy intake isn't matching what is considered true energy intake. So in terms of people under-reporting calories, if the individual is being extra active, then that would be requiring additional calories. So there are various equations. For instance, the Institute of Medicine has a set of equations that estimates the total energy expenditure. And what happens if we were to see, for instance, over-reporting of energy intake, that could be something where people maybe have an absorption issue, etc. But when we see under-reporting, what it's indicating is that they aren't reporting eating enough calories to sustain life. So whether that be through extra physical activity, which things like the doubly labeled water, if somebody is in energy balance, should take into consideration. The physical activity will alter the total energy expenditure estimates, but in the end, you would expect energy intake to be at least the total energy expended, unless people are trying to cheat the test.
Okay. Thank you. Next question. Do you believe the bias is unique to nutrition research?
Absolutely not. And that's the reason why I always have a hard time discussing this, because it seems like I'm taking aim at my own field. It's more that nutrition, compared to a number of other fields, is related to lifestyle. It's related to that quadrilateral that I showed, where when you tell somebody that a food is good or bad, you might be telling them that a part of their culture, especially if you're telling them a food is bad, that their culture is bad. Whether it be beverages, like I think of some of the cultures around fermented foods and fermented beverages, and you're telling them that their culture has been doing something that's deleterious, or that the thing that they enjoy is actually bad for them. And these are things we can't get away from as humans. Scientists and dietitians and clinicians, everybody has experiences with food every day. So we have our views on it, and it ends up being kind of entrained, whether we like it or not, into the research. And that's why we need to have as much research as possible. And I hope I made it clear that a number of these studies weren't necessarily bad. It was just whether it gives us a complete picture. And so we can't just stop at the one study. Nutrition is such a complex, integral field that it's something that will take a long time to be able to tease apart some of the effects.
Thank you. Next question takes us back to your second polling question. Can you clarify how the empty calorie percentages were determined? What about the calcium and protein in the yogurt?
Yes, so that's something that I've always struggled a little bit with. Those numbers I pulled straight from MyPlate and their descriptors of the empty calories. And there's three things that they generally consider to be an empty calorie. One is going to be the added sugars, one is going to be solid fats, and one is going to be alcohol. So in the case of a low-fat, fruit-flavored yogurt, my guess is the example they were using was going to be that I would assume it would have had to have been a sweetened, and they just didn't say that. Similarly, you could have, obviously there's the calcium and there's the complete proteins, and there's even in the low-fat yogurt, there's still going to be some healthy lipids in there. So it's trying to have a consumer figure out what is meant by an empty calorie is a difficult thing, and that's also why I brought up the red wine, is because people are told, oh, well, you know, the resveratrol and the phytonutrients and the red wine is supposed to be healthy, and yet we call it 121 calories or 121 empty calories, despite also saying elsewhere that it's something that has helpful properties. So that I believe is how they calculated it there. They just used the database based on the reported composition of the food.
Thank you. Next question. So much controversy over who has funded the study, with more or less immediate dismissal if industry is involved. What do we say? Any data?
There have been some people that have tried to look at that, and the results end up being a little bit mixed. So when looking at study quality, sometimes the industry-funded studies will look to be of a little bit higher quality, and that's because a lot of times there's more money to make sure that the study is done correctly. On the other hand, people have seen that industry-funded studies sometimes will end up supporting the position of the industry or the product, and it's unclear really whether that's an issue of publication bias or if they are creating studies that are going to, how do I phrase this, are designed such that a negative outcome likely won't be found. That's not biasing it. It's just asking a very specific question. On the other hand, you also see the opposite sometimes, where you'll see government-funded studies. For instance, the USDA just funded about $5 million for a study to increase fruit and vegetable consumption in children to decrease obesity. Well, there's not really any good evidence that increasing fruit and vegetable intake in children is going to decrease obesity. It might have other health benefits, but now we've got a situation where a non-industry funded source is funding a set of studies with a very directed aim as well. And so what I think we need to do is we need to engage all parties, and I think the first thing that needs to be done when a new study comes out is to look at the study, look at what questions being asked, and if the science is flawless, then we can look at who funded it. But a lot of times we don't even get to the point where we can say, the study is without fault, and then we're kind of distracting ourselves from the scientific pursuit.
Okay, Dr. Brown, thank you. We have time for one quick answer to one last question. I'm afraid we're running out of time. So the last question. This is one of the best webinars yet. Do you have data regarding the accuracy or bias of the many food bloggers who have come on the scene lately? If not, what do you think could be done to improve this situation?
I think the Sense About Science group, I'm not sure if they have data, but they've certainly taken those types of situations head on, where rather than necessarily arguing directly with the bloggers, I know that along with Sense About Science, there was a group that asked the Food Babe some questions, and it's a group of students that actually went ahead and they have an Ask for Evidence campaign, which is anytime you see something that says this will cure a disease or this is helpful or this isn't, is to stop and ask the company or the blogger or the individual, what evidence do you have of that? And they've done a great job getting some groups to stop and think, we don't really have evidence that this particular food is going to, clear up your acne or help you lose weight. And so they've actually removed some of their overstated beneficial claims, and hopefully it will also spur some more research so those claims can actually be investigated.
Okay, thank you. To be continued, right? Okay, I'm afraid we're out of time, just about. So I want to repeat the learnings from this webinar. Based on the webinar, the participants should be able to, number one, state potential influences of biases in nutrition research. Number two, discuss the importance of critically evaluating new research, that is, whether it confirms or refutes standard clinical practice or commonly held beliefs. Number three, describe steps to minimize misinterpretation of research. And number four, identify strategies for health professionals to use to objectively translate scientific knowledge to clinical practice. I'd now like to turn the webinar over to Amy Continelli, who will give you logistical information. Amy?
Thank you, Dr. Rippey. The Conagra Food Science Institute NutriBytes webinar details. Again, you will receive your continuing education credit certificate by email within 2 days. You can find the webinar, including a link to your certificate, if you have trouble via email, to download within 2 days at our website as well. And if you do have any questions or comments or concerns regarding the CT information, feel free to email me directly. And recent CEU webinars archived on the Conagra Food Science Institute website are all the ones that we have done in the past year or so, and you're available to get CEU credits by taking a brief quiz. Thank you, Dr. B.
Thank you, Amy. This is part of a series of webinars, the Conagra Food Science Institute NutriBytes webinar series. Our next webinar will be on May 6th, same time, 2 to 3 p.m. Eastern Daylight Time, 1 to 2 p.m. Central Daylight Time, and it's Colleen Isom and Chris Mogensen, and they will be talking about nutrition support for the bariatric surgery patient, when and why nutrition support is needed. The ability to register is available right now on our website. I would like next to thank Dr. Brown for a most enlightening and entertaining webinar on a very important topic, and I would like our participants to do us one more favor, and that is stay on the line for about another minute to take a brief survey about today's Conagra Food Science Institute NutriBytes webinars. We do take those comments seriously, and they help us determine topics for future webinars. Once again, thank you, Dr. Brown, and thank you to all of our participants for participating in today's webinar.